onto Azure. Okay, so most people have seen this sort of slide before. It talks to the difference between on-premise, infrastructure as a service, platform as a service, and software as a service, and the benefits of each. Okay, so software as a service is I just consume it. I don't have anything to do with the IT at all. I just use it. Pay as you go. That's things like Office 365 or Salesforce or something like that. Okay. Do it yourself is you do everything yourself. So if you build IT indoors, you've built the networking, you built the servers, you've installed the operating systems, you patched them, you installed the OSs, the applications, you manage everything yourself. The likes of Amazon would be a good example of infrastructure as a service. So they'll do all the donkey work to the low level and give you a virtual machine into which you'll install you'll manage your operating system, you'll patch it, you'll install your application, you'll do your own piece. Okay. Windows Azure was from day one 2 years ago. Was definitely positioned as platform as a service. It was positioned for developers to build applications.
Right, Dave, I'm just going to stop you for a second.
Okay.
Because we're having an issue with regards to the guys trying to dial in on the phones at the moment. Your conference ID isn't working. Is there something else that we can actually let these guys access on? I don't know whether it should automatically connect on the telephone conference.
It should.
It doesn't actually recognise anyone as presenting on there at the moment, and all sound is muted.
On the telephone only?
On the telephone only.
So make a split decision now. I think we'll just have to apologise, and we'll send the link to the recording because we are recording it. Okay.
Okay. Cool.
Sorry about it, guys. So yeah, sorry, Justice. I saw you come in there. We are recording this session. We'll put it up online either later on today or what day today? Friday, Monday. We'll do it. Sorry, guys. Chaos going on.
I'll let them on there.
So anyway, Windows Azure was definitely historically positioned as a platform as a service that people would develop to, okay? And this was how we positioned it, okay? So we said we don't care what you develop in, whether you're a .NET developer or PHP or Java or Eclipse or whatever you decided to develop in, as long as it ran on a Windows box, we'd run it, okay? So inside our data center, every server is ours, owned by us. Every server is running Windows Server 2008 R2. With a few exceptions nowadays, they're probably running Windows Server 2012. And then the majority of them running Hyper-V as well, which we'll get to, okay? So as far as Windows Azure is concerned, and some of the naming has changed for later on, but as far as Windows Azure is concerned, there's a compute function. The compute function is, think Windows Server in the sky. That's all it is, okay? There's a web role, think Windows Server in the sky with IIS turned on, it's a web server. There's a worker role, think Windows Server in the sky without IIS turned on. It's just doing compute functions. It's whatever executable you want to run. There is a stateless VM role at the moment. You do have the ability to copy up a Windows Server 2008 R2 box of your build and copy that and run it up there at the moment. It's stateless. And what I mean by stateless is when you reboot it, everything you were doing is gone. Okay? And the reason and the web role and the worker role are also stateless. The reason is because it's hiding behind a load balancer. The load balancer will give the request to any one of those servers, and therefore there's no state held anywhere. And the benefit of that to the developer was, I start with maybe 2 servers, and it's a busy old website. Have 3, have 4, have 10, have 100, have 1,000, and you just scale up the number of servers depending on how much workload is going on. And then you scale it back down when the workload's not happening, and you turn it off if your business adventure failed. It costs you nothing, okay? So it really was about pay as you go, scale up, scale down. As far as SQL Server, and that's the compute function. Storage, just think Windows Server with a disk, and we just use that storage for either blob storage. You can mount that blob storage as an NTFS file system. But this concept called tables, think very big Excel spreadsheet in the sky, where you do all the indexing and you worry about how your data looks. And the other piece of storage is a queue. And the benefit of a queue, or the reason for a queue, was if you have a web role at the front talking to a worker role at the back, how do you know that any one of those 10 or 15 or 20 servers at the front spoke to any one of the 10 or 15 in the middle? You have a queue between the two that dealt with how the messages get sent back and forth. And that was how you architected your application. Web role at the front, talking to a queue, talking to a worker role at the back, which potentially went and did its donkey work on the SQL Server database at the back. And that's how you architected an application. Which brings in SQL. SQL is just SQL Server. Think SQL Server in the cloud. Nothing clever than that. We're not quite on par with what you can do on-premise. So we're catching up in that regard, okay? So for instance, you can't at the moment do You might be able to moment do. Yesterday you couldn't do analytics, for example. Maybe that's coming. And then Windows Azure App Fabric is how do you join it all together? How do you join all the bits together with the cloud and on-premise, and how do you make sure that when you authenticate against something that your authentication happens somewhere else and you can use the whole shooting match as an application? Okay? So that's my 1 minute explanation as to what Windows Azure is. Okay? Windows and SQL in the cloud. Okay? Just out of interest, because I'm a techie, I find this interesting. Inside any old data center, that's what a data center looks like. So it is. It's rows upon rows upon rows of racks full of servers, nodes in this respect, and you'll aggregate them all together with load balancers and aggregators to make sense of it all, and then you'll feed all that back up to the data center routers where the internet comes in. Okay, that's a common design for any old data center. If you take one of those, just pick those that little bunch on the right hand side. What we do with Windows Azure is we do this. We call that an Azure cluster with thousands of nodes, okay, thousands of servers. Now, how many servers is depending on how big the cluster is, and the size of the cluster is depending on how many people are using it, and which country it is in, and all sorts of things. So just think thousands of servers, and we've at least 100 servers in a rack, so a dozen racks, maybe something like that, okay, or more. We design for failure, so we understand that things are going to go wrong. The things that can go wrong in that cluster are the top of rack switch, i.e. I lose a whole rack, or a server itself, or you lose a server. I need to mitigate all those risks in software. So Azure is completely about doing it all in software. We don't want to have any old proprietary hardware. We don't want expensive, high availability hardware. We want off-the-shelf, cheap servers, the more the merrier, and we do it all in software. So the way we do it is at the concept of a fabric controller, of which there's one primary in each. There's one primary. There's a fabric controller per rack. One of them is a primary, and all the rest are secondaries. Okay? And the reason we do that is if the primary dies, someone else can spin up and be the primary, so that knows what's going on. Fabric controller knows everything that is going on in that cluster, okay, and is in control. It's almost like the operating system for the cluster, if you want to take that analogy in your head, okay? But it knows how to cope with planned downtime and unplanned downtime. In the event of unplanned downtime, something breaks. The fabric controller knows what to do. Even if the primary fabric controller breaks, I still know what to do, okay? And for planned downtime, I'm doing an upgrade. I'm doing a rolling upgrade. I can manage that, okay? Make sense? Within one of those nodes, it's just a server. Just think Windows Server. So the host partition, Windows Server 2008 R2. The Windows Azure hypervisor, think Hyper-V. It's Hyper-V. It's just been tweaked a little bit to cope with thousands of servers in a cluster rather than the current 16 or whatever it is. On each physical node, with an image repository of all the VHDs of Windows that we're ever going to spin up, and any kind of role stuff or your application zip files. And then what happens is, you come along with your application or your request for Azure to do something, the fabric controller goes, okay, I need to spin up a couple of boxes for you. I'm going to go to that host, that physical node, tell it to go and check out a VHD from the library, create a virtual machine, spin it up, enable these roles, put these bits on it, but ta-da, Bob's your uncle, there's your virtual machine running. Okay, that's as simple as it is. It's just Hyper-V. To make it make a bit more sense, if you me trying to make sense of it. Okay, so there's my cluster, 3 racks in this instance. I've tried to make it look like each server in that each rack has got 8 processors. They might well have 8 cores, but it's kind of irrelevant because it's virtualization. But think 8, okay? And the reason I've done 8 is because in Azure you build a small, a medium, a large, an extra small, and an extra large virtual machine, and within that is how many processors it's got. So small's got 1 processor, medium's got 2, large has got 4, extra large has got 8, and an extra small's got half. Not that you can half a processor, but you get the idea. So the way this works is, my service I want to deploy, I've defined it's got 3 servers at the front end, the presentations here or the web tier, and 2 at the back. So the app fabric goes off and spins up 3 medium-sized VMs, okay? And because it's 3, I deliberately put them on 3 separate racks. That's a fault domain, so if a whole rack went down, I've still got 2. I could still provide you with your service level agreement, your application's still up and running, whilst I spin up another one, okay? As far as the back-end one is concerned, there they'll go. I deliberately put them as close as I can to your frontier, On-server communication is much quicker than going out to the network. That just makes sense, okay? That's ridiculous gigabits per second rather than not so quick gigabits per second over the network. That just makes sense. And then what I do is with the load balancer itself, and we currently use hardware load balancers. All that's changing soon. If you've been following Windows Server 2012, we introduced something called an extensible switch, which lets me do all the switching stuff in software, which lets me get rid of physical load balancers. I can do all this stuff in software. And then the load balancer configures itself up. So my external mycloudapp.net with its external IP address, I resolve that to internal IP addresses to my 3 or 8 or 5 VMs in that instance. Okay, makes sense? And off it goes, application's up running. And then in the instance of a failure, in this instance I'll take a server going down, the service level agreement was to have 3 of those frontier boxes. I lose a server, I therefore lose that server from the load balancer. The fabric controller is configured to go off and instantly spin up another one as quick as it can, and which I'll configure in. Okay, so I'll go back that slide. That's Windows Azure as of the day before yesterday, or as of yesterday. Okay, so